Okay, hello. Thank you everyone for joining the stream. Today we're going to be talking about a new product that we have, or a new tool that we've released called LLZK. So for those of you who aren't aware, LLZK is an intermediate representation that we created for ZK languages. We announced it recently, and when we announced it, we got a lot of good questions about, what exactly is LLZK, what can it do, and what can't it do. So we thought it would be useful to host this AMA session where people can come and ask us about, current features that LLZK might have, as well as features that we have upcoming for LLZK to see, whether LLZK might be the right fit for them. And so for that reason, we, like I said, decided to host this AMA, and we invited the team behind LLZK in order to answer all of the questions that you guys might have. And so just to give a couple of introductions, I'm John. I'm the CEO of Veradice, which is the company who created LLZK. We also have Kostas, who is the CTO of Veradice, and Shankara, who's the head of ZK tooling and was in charge of the development of LLZK. And then we also have Ian Neal, who's one of the senior R&D engineers, and Tim Hoffman, another senior R&D engineer at Veradice, who both were instrumental in the construction of LLZK. So with that, we're here to take any questions that you might have, but also we thought it might be useful to start by kind of introducing what is LLZK and, give everyone a chance to kind of possibly get some answers to some questions that we've heard already. And so we're just going to start out with a couple of general questions. And the first question that we thought it might be useful to discuss is, what is the problem that LLZK solves? And so I guess, Shankara, do you want to go ahead and take it on?
Yeah. So the problem LLZK solves is that in the ZK space, when we first kind of looked into it, I think a lot of ZK languages are quite siloed. So what we mean by that is that every ZK language kind of has its own compiler, and each compiler does a lot of the same stuff, like it extracts constraints, optimizes them, and then converts them to suitable forms. And so, on the other side, there's also a bunch of work done by us and other companies about building security tools for ZK. And at first, they were kind of building tools specific for specific languages. And so it was like kind of a lot of effort to kind of take a tool that we built for one language and have it apply to different languages. So I think like in the normal programming world, we have frameworks like LLVM. And so LLVM is kind of this IR framework that different languages can kind of compile down to. And tools are built on top of LLVM that can be applied to different languages, right? So what we're trying to do is build similar infrastructure for the ZK circuit space. Yeah.
Okay, great. And so that kind of introduces what it is that, or what is the problem that we identified with LLZK. And so next, let's maybe talk a little bit more about what LLZK is and how does it address this problem.
Yeah, I'll go into that. So yeah, like John said, it's an intermediate representation for zero-knowledge languages. But it also has a reusable compiler stack, like Shankar was mentioning, that multiple ZK front-end languages can compile into LLZK IR, and then we've developed and are planning to develop more like analysis tools, optimization passes, and verifiers, backends that all consume that single language, the LLZK IR. And other companies, other people can build tools themselves that consume the LLZK IR. So it takes this siloed infrastructure, siloed domain, like Shankar was mentioning, and brings it to a common language that kind of breaks up what was like a multiple repeated effort across different, for each different languages, into a single effort to target the LLZK IR, both from the front end compiling to that, and then any backend tools and optimizations, verifiers, whatever, targeting only that language. It should be able to represent all, if not, or most at least, ZK languages. And we will go into in a little bit that we've already worked on the front ends for a few languages and have some back-end tools that we support already. But yeah, in theory, it brings together and unifies a lot of the disjoint effort that is going on in the ZK ecosystem right now.
Okay, great. And so, kind of the last question that we've heard through, comments on Twitter and stuff like that is, what is the roadmap for ZK? So what is it that we're planning on doing with ZK in the future, or with LLZK in the future?
Yeah, so like it's worth mentioning here that the initial funding for LLZK came through the verification efforts from Ethereum Foundation. And we are very grateful about that. And then in accordance with that, we continue working with the Ethereum Foundation to build interesting tools on top of LLZK. So the next one was coming into the pipeline. It's going to be a ZK verifier that our team recently published a paper about in CAV, and it's going to be a verifier that makes sure that the constraint generation logic of your circuit is equivalent to your constraints. And as part of this project, we will also have to add support for CIRCOM, which is not supported yet in LLZK. And then in the future, we're going to also expand support for Plonky 3 and Hello 2, which both of them have kind of some limited support already in LLZK. And finally, in the not much of a distant future, we're gonna have support for witness generation, which is again lacking in the current LLZK infrastructure. And beyond that is actually up to the people that want to build on top of LLZK. They will define the roadmap. We hope they will build interesting things on top of LLZK. And of course, if people have any interesting requests or features, we are here to both help build some of those and also guide them on how to build things on top of LLZK.
Okay. So we've gotten the first question from the comments. Why don't we go ahead and address that, which is a question that we've gotten pretty frequently, and I think Kostas already started addressing. But what ZK languages are we planning on supporting in the future? So I think Kostas already mentioned that we're planning on supporting Plonky 3 and Halo 2, but can someone expand on that?
Yeah, I can talk a little bit about that. Just to make a note that we already have some support for Zergen, so RISC-Zero's circuit language. So we have a prototype front end for that's available on our GitHub as well. And we do have limited support for Halo 2 and Plonky 3 languages. And our next steps are, one, to continue expanding our support for Halo 2 and Plonky 3, as well as part of this work on our verifier, which was, as Kostas mentioned, recently published. We're going to be working on a CIRCOM front end for that as well. So we'll be supporting CIRCOM and LLVM or LLZK. And then also driven by community effort as well, as what we would hope is that anyone who's interested in developing a LLZK backend for their language could also get involved in development of front ends. And of course, we'd love to be involved in that as well. So, our Veridice's plans for the things that we want to develop being, continuing support for Plonky 2, or Plonky 3, Halo 2, and CIRCOM, and then of course seeing what develops in the community as well and helping out there. Yeah. Okay.
Yeah, I guess, are there any other languages that we might have on the horizon other than that?
I think we'd be interested in Noir. Having an LLZK backend for Noir would be cool.
I think that's come up a couple of times, both from us and Aztec, and so I do think that is something that we're very interested in looking into.
Formaland just asked about that as well.
Oh, Formaland just asked about that. Okay.
Definitely Noir, yes.
Yeah. So I do think that Noir is a possibility. They also have a pretty low level intermediate representation as well. And so I think that an interesting thing would be the ability to translate back and forth between like LLZK and ACIR, which is their intermediate representation. Speaking of Formaland, though, why don't we go ahead and address their question, which is, for Plonky 3, do you plan on importing the low-level constraints or also a more high-level structure like loops and arrays? I
can address that. So I think like for now, our limited support only has the constraints. The main thing is that I believe we have to extend the Plonky 3 builder interface to capture some of those like high-level control flow operators. I think that would make it like potentially more amenable to analysis or verification. But right now, we're just importing the low-level constraints. Be interested in sort of prototyping a possible, how we can sort of extend Plonky 3. I think part of that will require sort of some extensions to Plonky 3. And I'd be interested in seeing that. We're also interested in like maybe a builder for witness generation in Plonky 3. Some witness generation code will be hard to import because it's like kind of arbitrary Rust, but it would be nice to also be able to import some of the witness generation code so we can do some analysis on comparing the witness generation and the constraints. That's kind of where things are at.
Yeah.
It's the same issue with, I think, Halo 2 and a lot of these embedded DSLs.
Can you give a couple of hints on what might be needed in order to support some of the higher level control flow?
Yeah, I was saying that the builder API should be extended to kind of mark something is like some maybe loop constructs can be themselves part of the builder API. But I don't know. I think in general that might be one direction to go.
Okay, great. So another question that we got in the comments, which I think we've had a couple of times, is why did we decide to build LZK on MLIR? So I guess Tim, do you want to take that?
Yeah, I'll take that. Yeah, so MLIR provides a lot of the infrastructure needed for developing other IRs and DSLs and stuff. So, and it provides a lot of built-in like compiler analysis and tools that help ease that process or provide some things for free if we are built on top of MLIR. And then ultimately could help in the witness generation because we can just define transformations down to LLVM or some of the other like a C target or something like that provides some infrastructure for free. So we didn't have to build everything from scratch. Some of the other like front ends that we've looked at, Zurgen, for example, was also built on top of MLIR. So being in the same like stack helped speed up that process of development. Yeah, I don't know if anyone else has thoughts, but those are some of the benefits I know from MLIR.
I think there's like I just was going to say there's a kind of like a big parallel between like the ZK development and probably a lot of the AI boom with using MLIR. There's like a lot of kind of AI frameworks are being built on top of MLIR, and there's like kind of these nice arithmetic dialects and optimizations that we think can be like ported to the ZK domain. So that's kind of also some reason to use it. Like a lot, there's kind of a big boom in MLIR, big community. So yeah.
Right. And I guess one of the nice things about MLIR as well is it's connected to LLZK in a pretty direct way. And so especially for things like witness generation, you can pretty much create a translation to LLZK to provide the backend compilation as well, which makes things like pretty nice for that aspect as well.
And it also provides such a nice way of converting between different ZK languages that have different sets of features. So internally, LLZK has several different dialects that sort of represent different features that languages may or may not have. And when you have, a language at a higher level and you need a target, say like a R1CS backend target that doesn't have high level constructs, you just define the appropriate conversion passes to translate those higher level dialects into lower level R1CS code. And so this is kind of what MLIR is designed to do, and it's precisely the things we need to do for LLZK and ZK languages. And so it's just really built well for what we needed to do.
Can you give an example of what like high level thing might need to be?
Sure. Yeah. Like for example, CIRCOM's got templated structs that you can provide, template parameters for defining the size of arrays, and you can instantiate those in different places. Well, you can't do that in R1CS, and so we have a pass that will explicitly instantiate those structs, and so you'll create new structs that instead of having the template parameters, they have the template parameters removed, and the template parameters are represented as operations in a different dialect. And so you define a conversion pass to eliminate those kind of operations. And so we, eliminate the struct parameters, and then we eliminate structs themselves to just get down to the constraints that you need for R1CS. And so you take this problem of how do we take this high level language and get it to the constraint system to just incrementally removing features until you have what you want to give your R1CS output or whatever backend you want.
Mm-hmm.
And I guess another important thing, especially for ZK where correctness is paramount, is that there is also already research of kind of verifying that transformations you do between transformations you do on top of MLIR are actually equivalent. And we are already planning to kind of take that into LLZK, and the fact that there is a kind of already research and infrastructure to do that was kind of very, very important to us.
Okay, great. So let's move on to another question. And so this one's also from Formalan. So have you looked into whether the precompiles for different ZK VMs can be reused or even compared in terms of speed? Would it be easy to reuse precompiles between different ZK VMs, or is there a lot of plumbing that you would need to do? So this is specific to ZK VMs and reusing precompiles, but you can also think, kind of reuse of arbitrary ZK circuits being baked into this as well.
Yeah, that's a good question. I don't think we've actually explicitly looked into it. I suspect there would be some amount of plumbing to do because some of these precompiles are kind of different ZK VMs have different architectures, and some of the precompiles take advantage of that. But it would be good. But it would be interesting to think about kind of maybe a library of precompiles that could be used across different ZK VMs, and designing that would be kind of interesting. I'm not sure how easy that would be to do.
Okay. So if we assumed that all ZK VMs had the same, kind of architecture, do you think it would be easy to reuse some of the...
I think it would be easier, yeah, definitely.
Okay. And I think that there's a kind of a similar question here that it might be useful to discuss about kind of reusing circuits across languages. So do you think that this would allow us to now allow someone to write a circuit in CIRCOM and then use that circuit that they wrote in CIRCOM in a Halo 2 circuit?
Yeah, you could. I mean, I think that obviously there's going to be some incompatibility depending on the type of proof system, probably that's going to make it won't make sense to necessarily use a Planckish, a circuit that's intended for some kind of Planckish arithmetic in R1CS necessarily, but especially for things in this targeting the same arithmetization, there's definitely a lot of room for kind of reusability there. Yeah, for sure.
Okay, great. So another question that we have from the chat is, are there people building on top of LLZK?
Yeah, there are a few different groups building on top of LLZKs. For example, the Formal Land folks have a grant from the Ethereum Foundation to kind of build a kind of translator from LLZK into Rock, and we're really excited to see where that goes and also help them with that. And there's additional grants that I think the Ethereum Foundation is either approved or in the process of approving about like a lean backends for LLZK. I think that would be very interesting to see. There's been a lot of work on sort of MLIR to lean. And I think we can take advantage of that to get some other types of formal verification for free, in addition to the kind of automated verification that we're planning on building on top of LLZK. So there's a lot of I think exciting stuff there. Other collaborations we're doing to kind of build front ends for LLZK so that we can verify different protocols. So I think it's still quite early, but people are starting to build on LLZK.
Okay. And so with all the stuff that's being built on LLZK, what would you say would be the benefit for someone to add support for LLZK into their language?
Yeah, so I think there's a few things that, as we mentioned, I think one of the biggest upsides right now is sort of the security aspect. I think we're building a lot of tools, both open source and closed source, and then there's people building backends to proof systems like Lean. And so what you will start to, having a backend to LLZK means that you now have access to all this security tooling that we're building. And so you get that, that's something that you can get from building a front end to LLZK. So, and then, as we kind of build out LLZK more, we're hoping to get, we have optimization passes now to kind of prune redundant constraints. And so, your programs written in your language can take advantage of that. So, yeah.
Okay. So I think we're out of questions in the comments, but there's a few other questions that we've had from people on Twitter and stuff like that. So one question that we commonly get is, what are the the ZK features that are currently supported by LLZK? So for example, does LLZK currently support lookups or folding or something like that? So Tim, I guess, do you want to take this?
Yeah. So we have a plan to support lookups. It's not fully implemented yet. And then we haven't discussed support for folding yet. Was that the full question, John?
Yeah.
Okay, Shankar, do you want to add anything?
Yeah, I think so. I think I think folding is something that would be quite useful, especially as we get bigger and bigger circuits. So that is a sort of a plan, but we have not gotten to that yet. And but lookups, we have sort of the syntax for lookups, and then I think we need to sort of build out. I think this would be a great contribution, is kind of building out the sort of backends for the lookup arguments themselves. So yeah, that's something in our to-do list.
By the way, I think there is another question in the chat about how people can get involved in LLZK development.
Okay, I missed that.
Yeah.
So why don't we go back to that?
Yeah, so I can answer that one. There's a few different ways. So as LLZK is fully open source, there should be a GitHub link in the YouTube description. So we are happy to accept PRs, but we also have a Discord channel that you can join, and we'd be happy to like chat with you there about ideas you have about what you want to add onto LLZK, and we can like help you figure out the best way to kind of achieve what you want on top of LLZK. And we also have a docs page for LLZK on our website. And so you can kind of use that to sort of understand what we currently have and what we're missing. And so, yeah, I think those are the kind of the three big avenues to kind of get involved. Yeah.
Are there any types of contributions that we're especially excited about people, in the community making?
Yeah, I think some of the stuff, maybe it's some more backends for LLZK, but by backends, I mean like kind of target like backend arithmetizations, and like kind of also if somebody wants to collaborate with us on witness generation, making like efficient witness generation, that would be great. And then, as I mentioned, like kind of the backend support for the lookup arguments, support for different types of lookups would be great. And yeah, I think those are some of the ones that come to mind. Do you guys have any
Or
other?
like front ends, of course, like,
Yeah.
I would greatly appreciate it.
Yeah, for sure.
Yeah, front ends would be great.
Yeah, and I know we have some open issues in the GitHub issue tracker for some smaller features or things we think would be good to add to the LLZK framework. If people are interested in any of those, like, we're welcome to take contributions or PRs, like Shankar mentioned, from those, or anything else that people think would be interesting to add or useful to add.
Okay, so we have another question in the chat from Formalan. So in terms of programming language, what would you recommend to build plugins, C++ or the new Rust version?
Tim, do you want to give this a shot?
Yeah, I can. So we have primarily built out LLZK in C++, using the native MLIR stuff in C++. But yeah, we have another repo, LLZK-RS, that is a Rust API to build out in LLZK. It's not as developed, and everything may not be supported, but it's a work in progress. And yeah, definitely we want that to be an option for people to make LLZK more accessible to more audiences and more users.
So I guess maybe the answer to that is whichever language you prefer, but maybe look at the Rust API to make sure it has everything you need first.
Yeah. Yeah, and go ahead. You can, on that repo too, you can talk to us on the Discord or in the issue tracker on there, and say, hey, I would like to use this feature. This is what I want to support, and it's not there. And we can definitely see about working together to get that supported. And
are there Python bindings for?
Are there Python bindings? Is that what you asked?
Yeah.
There are. It is. So from the MLIR side, they have support for Python bindings, and I think we had enabled that at one point. I'm not sure if it's still enabled, because I think there were some issues there, just like from the MLIR side, it's kind of in a beta stage, I think, still. I don't think it's fully capable at this time.
Okay, so it sounds like you could use Rust or C++, or if you wanted to, you could use Python. But if you want to use Python, maybe let us know, and we can try to help you a bit more.
Yeah, and there is always the textual representation that MLIR produces and can consume. So if you're really just looking to get out of any of those ecosystems and use some other language for your compiler, and you want to target LLZK-IR, you can just directly produce textual output. Not recommended for sure, because there's a lot of issues you can run into there with just producing the wrong thing very easily, but an option.
Okay, great. So it looks like we're just about out of questions. And so I think that we've hit the 30-minute mark. So that's probably a good time to wrap up this stream. So if anyone has any questions in the future and they were not addressed within this AMA, then consider joining our Discord and asking there. We're always happy to take questions. If you have any issues, then consider posting an issue within the GitHub issues, or if you have any problems interacting, posting issues, asking in Discord. Any of these are great ways to get in contact with us, and we're very excited to continue growing LLZK and to help anyone with developing projects on top of it. Okay, and I think with that, we can probably close. So thanks everyone for joining, and happy developing.
Exciting.
Thanks, guys.
Thank you. Yeah.
Guys.